Our first example, it's actually what we just did in the graph. So 1 over n, and then times alternating sign there. So this is the alternating harmonic. Let's write what the a sub n term is. Looking at that, before we got to this section, we would have said the a sub n is the whole thing, but here in this section, we're saying it's just the part that isn't the alternating sign, so it's just 1 over n. Let's try the alternating series test. What does it require? So the first thing it asks is the a sub n term, is that decreasing? So is a sub n decreasing? Is 1 over n decreasing as n increases? Yep. So we're good there. And the second part, it asks, is the limit as n goes to infinity of a sub n equals 0? Is the limit of 1 over n as n goes to infinity 0? Yep, 1 over n is decreasing right to 0. So we can say yes there. So the alternating series test says that the sum converges. It doesn't say what the sum converges to, and it takes a little bit fancier stuff to find out what it converges to, but it so we'll say a side note, this sum converges to log 2, which is kind of interesting. It seems a little surprising that that stuff would produce something about log, but actually if we come back and look at this polynomial that we started here, you can see how we're getting an alternating harmonic, right? 1 over 1 minus 1 over 2 plus 1 over 3 minus 1 over 4, as long as these x terms are all 1. So if I had an x there of 1, that would be log of 2. So it seems to actually work. Let's try another quick one. Let's try the sum of -3 to the n. That's not in typical alternating harmonic form. Let's rewrite it in alternating harmonic form. We could say that's -1 times 3 to the n, which would then be -1 to the n times 3 to the n. So what's my a sub n here? It's just the non-alternating part, so it's 3 to the n. Is it alternating? Is this thing alternating? Yes. Part 1 of the alternating series test would ask, is a sub n decreasing? Is 3 to the n decreasing as n increases? No, it's increasing quite quickly, right? It goes 3, 9, 27, 81, etc. So that's not decreasing, so we don't even need to ask part 2. In fact, that limit's also not 0. So what can we say from the alternating series test? So we'd say stop. The alternating series test is inconclusive. Can we say anything about this sum? Well, it fails the nth term test, right? The nth terms are not approaching 0, so we know the sum is divergent. But the point here is to talk about the alternating series. Let's try another slightly interesting one. How about the sum of cosine pi n over n squared plus 1? That does not look like an alternating series, does it? Well, often when we don't know what's going on, it's a good idea to graph stuff. So let's try graphing just the cosine pi n to start. At n equals 0, we didn't even really say where we start, but that's fine. At n equals 0, we'd have cosine of pi times 0, which is cosine of 0, which is 1. So we'd be up here at 1. At 1, we'd have cosine of pi times 1, which is cosine of pi, which is -1. So we'd be down here at -1. At 2, we'd have cosine of 2 pi, which is positive 1. So we're up here again. At 3, we are at cosine of 3 pi, which is -1. So altogether, our cosine is doing this, and that's giving us alternating signs, +1s and -1s, right? Because we're only really paying attention to it at the integers here. So that's doing the alternating for us. What would you say a sub n is? It's the part that's not doing the alternating, so it's 1 over n squared plus 1. And then let's try the alternating series test. The series is alternating because we've got the alternating signs times some other function. So part 1 of the alternating series test is a sub n decreasing. So is 1 over n squared plus 1 decreasing? Well, 1 over n squared decreases, and 1 over n squared plus 1 is just a tiny bit smaller because the denominator is a tiny bit bigger. And so, yes, that sequence is decreasing. Part 2 is the limit as a sub n, limit as n goes to infinity, a sub n equal to 0. If you plug in larger and larger n values here, does this sequence go to 0? Yes, it does. So then what does the alternating series test tell us? It says that the sum converges. Doesn't give us any hint as to what the sum converges to. Alternating series are actually kind of nice about estimating what the sum converges to, which we'll talk about in a later video.